Hello students, welcome to 15th lecture of surface chemistry. In previous lecture, we were discussing about the properties of colloidal solutions like colligative properties in which effect on different type of properties of solutions will be observed like elevation in boiling point, depression in freezing point, or lowering in vapor pressure or osmotic pressure. Tyndall effect, that means when we pass a light beam through the solution, it will scatter the light from all along the direction, and that's why we can see the illuminated path of the light from the solution. Then we discussed about the colors of the solution, colloidal solution, and as we discussed in that, depending on the angle of the viewing, you may see different type of colors of the same solution. Then Brownian movement, that means random motions of the particles due to the transfer of kinetic energy with the collisions. So because of Brownian motion, colloidal solutions are stable. That means they will remain suspended or mixed with the medium. Phase particles will remain mixed with the medium particles. Brownian motion or moment is one of the factor affecting the stability of colloidal solution. Then we discussed about the charge on colloidal particles. Colloidal particles carries positive or negative charges. They are not neutral particles, and this is the second factor which affects the stability of colloidal solutions. Because of similar charges of colloidal particles, they do feel repulsion from each other, because as we know, like charges repels each other and unlike charges attracts each other. So because of similar charges on the colloidal particles, they will repel each other, and so they do not mix with each other and do not create a larger mass which precipitates later. And because of this charge formation on the surface, they will create a double layer formation. And lastly, we discussed about electrophoresis in previous lecture. That means you can identify whether the particles of a phase are positive or negative using electrophoresis method. We discussed about simple method and instrumentation of this method, as we can see in this image. If particles are negatively charged, then they will feel attraction towards the anode because anode is positive. And if particles of colloid are positive in charge, then they will feel attraction towards the cathode, which is negative in charge. And now we will move to the next point, which is coagulation or precipitation. So stability, as mentioned earlier, of lyophobic particles depends on the charge. As mentioned in previous points, if colloidal particles carry similar charges, then they do repels each other and do not mix with each other. So if you can remove the charges on colloidal particles, then they won't feel repulsion from each other. And there is a possibility these particles, neutral particles, will combine with each other and it will create a larger sized mass of bunch of colloidal phase particles. And because of a larger size, this particle will feel more gravitational pull and kinetic energy effect will be decreased, or Brownian motion of a larger sized particle will decrease, and due to that it will settle down at the bottom of the container, and we can say that it is precipitated or coagulated. The process of settling of colloidal particle is called coagulation or precipitation of salt. That means in coagulation process we are actually removing the charges on the colloidal particles, or we are giving them similar charges so they do not feel repulsion from each other, and they will combine with each other, and later it will be removed from the remaining solution. So here are few methods mentioned how can we do it. So first is by electrophoresis. The colloidal particle move towards the oppositely charged electrodes, get discharged and precipitated. That means with this type of instrumentation we are actually removing the charges on particle, because as we can see, negatively charged colloidal particles are attracted towards the positively charged anode. That means they are opposite in charges, and that's why they will neutralize each other, and if particles are neutral, then they will precipitate out. Second method is by mixing two oppositely charged sols. Oppositely charged sol when mixed in equal proportion, partially or completely, they will separate out from the solution or precipitate out. Mixing of hydrated ferric oxide which is positive and arsenious sulfide which is negative bring them in the precipitated form, and this type of coagulation is called mutual coagulation. Next is by boiling. When sol is boiled, the absorbed layer is disturbed due to the increased collision with the molecule of a dispersion medium, because collision increases with increasing energy. Collision is one type of kinetic energy, and if you are providing temperature to the solution, then it will absorb more amount of energy, and heat or thermal energy will convert into the kinetic energy. So that's why at higher temperature gases expands. This is the same reason, because of movement of gaseous molecules increased with the increasing temperature, they will move away from each other. So same reason is applicable here. Because of collision, layer will be disturbed. This reduces the charge on the particles and ultimately leads to settling down in the form of precipitate. Next is by persistent dialysis. On the prolonged dialysis, traces of the electrolyte present in the sol are removed almost completely, and the colloids become unstable, ultimately coagulate. Now we already learned that dialysis is one of the filtration process or one of the purification process for the colloidal sol. So if we continuously carry out the dialysis process, then they will even remove the required electrolytic particles or ions, because of which colloids are stable. Okay, that means perfect amount of electrolyte is required to stabilize the sol. If amount of electrolyte is less than required, then particles coagulate, or amount of electrolyte is more than required, then still particles will coagulate. So if we disturb the balance of the amount of electrolyte present in colloidal sol, it will precipitate. Either you can increase the quantity or you can decrease the quantity. With the help of dialysis, we can decrease the quantity of electrolyte, and that's why balance will be disturbed, and due to that particles will coagulate. Next is addition of electrolyte. That means opposite process of fourth point, persistent dialysis. In dialysis we are actually removing the electrolytes, and in next point we are actually adding the electrolyte. So again we are disturbing the balance. When excess of electrolyte is added, the colloidal particles are precipitated. The reason for that is colloids interact with the ions carrying charge opposite to the present on themselves. That means if we have positively charged colloidal sol, then addition of electrolyte will produce positive and negative both type of ions. Then positive colloidal particle will feel attraction towards the negatively charged ion. And same thing is applicable for negative colloids. Negative colloids will feel attraction towards the positive ion. And when these two opposite charge carrying particles mix with each other, they neutralizes each other, and due to that coagulation occurs. The ions responsible for the neutralization of the charge on the particle is called the coagulation ion or coagulating ion. A negative ion causes the precipitation of positively charged sol and vice versa. Now this point mentioned in the same category is important. So keep in mind, questions related to this will be asked either in MCQs or in descriptive. So let us start. It has been observed that generally the greater the valence of flocculating ions added, the greater is the power to cause the precipitation. Now flocculation, that means process to produce floc, and floc means loosely held clump of small sized particles. That means we can say that floc means precipitates, and flocculation, that means process of producing precipitates. This is known as Hardy-Schulze rule. In the coagulation of negative sol, the flocculating power is in the order of Al plus 3 is greater than Bl plus 2 is greater than Na plus. That means higher the charge, more will be effect. Now flocculating power, that means suppose you have 10 colloidal particles and you want to neutralize them so that they can precipitate. So let us say for that our requirement is 3 sodium ions. You need 3 Na plus to neutralize 10 colloidal particles. Then requirement of Ba will be less than 10. Requirement of Ba will be 2. You require 2 Ba2 plus to neutralize 10 colloidal particles. And for aluminium your requirement will be 1. 1 aluminium plus 3 particle can neutralize 10 particles of colloids, or charge will be removed from them. Okay, so this is for comparison purpose only, actual figure will be different. And same is applicable with negative ion. Higher the charge on the negative ion, more will be flocculating power. So that means minus 4 ion is more effective than minus 3 ion, and minus 3 is more effective than minus 2. Minus 2 is more effective than minus 1. That means higher charge can neutralize more number of colloidal particles than the lower charge. The minimum concentration of electrolyte in millimoles per liter required to cause precipitation of the sol in 2 hours is called coagulating value. The smaller the quantity you need, higher will be the coagulating power of the ion. That means suppose we have negatively charged colloidal particles, and in 1 liter quantity of Na plus, requirement of Na plus for completely precipitate out the sol in 2 hours, let us call it in millimoles, our requirement is 3 moles. Then for Ba it will be 2 millimoles, and for aluminium it will be 1 millimole. All of them can cause similar effect. Now let us talk about the coagulation of lyophilic sol. Previous points were mentioned for lyophobic sols. So there are two factors which are responsible for the stability of lyophilic sol. These factors are charge and the solvation of the colloidal particles. When these two factors are removed, lyophilic sol can be coagulated. This is done by first by addition of electrolyte and second by addition of suitable solvent. When solvents such as alcohol and acetones are added to the hydrophilic sols, the dehydration of dispersed phase occurs. Under this condition, the small quantity of electrolyte can bring about coagulation. Okay, that means because of higher stability of lyophilic sol, precipitation of them it is quite hard. Next is a protection of colloids. Lyophilic sols are more stable than lyophobic sols. This is due to the fact that lyophilic colloids are extensively solvated. That is, colloidal particles are covered by the sheath of the liquid in which they are dispersed. That means all of the liquid particles or medium particles will surround the colloidal particle, lyophilic colloidal particle, because that both of them feels attraction towards each other. So due to the attraction, our solvent particles or medium particles will be present around the colloidal particle. That means they are protecting them. So lyophilic colloids have unique property of protecting lyophobic colloids. When a lyophilic sol is added to lyophobic sol, the lyophilic particles form a layer around the lyophobic particles and thus protect the latter from electrolytes. Lyophilic colloids used for this purpose are called protective colloids. That means suppose you have a lyophobic sol like this, and when we add protective colloids in them, that means lyophilic sol, they will cover this surface like this. Now these type of particles are stable against the electrolytic addition, because on the surface we have lyophilic sols, and as we know lyophilic sols are stable, and lyophobic sol which is present inside the surface covered with lyophilic sol, they are protected from the addition of external electrolytic particles. Okay, so now they are stabilized as well. Now, if you find any difficulty regarding to these properties, then feel free to ask, and we will move further in next lecture.